Hi, everyone. Welcome to Cloud Native Live for Wednesday, May 22nd. I'm Taylor Thomas. I'm one of the CNCF ambassadors that helps host this. And if you're not familiar with Cloud Native Live, this is an event that happens very often in which we get to see the technology behind Cloud Native and how it all works with hands-on demos and explanations. And so, as it is a CNCF event, this is governed by the CNCF Code of Conduct, which basically boils down to just be nice to one another. Please make sure you keep your comments and your questions appropriate, and we're looking forward to having a good stream. Today, we have Ben and Flynn here talking about some really awesome stuff with Backstage and Linkerd, so I'll let them introduce themselves and their topic.
You want to go first, Ben?
Yeah, sure. So my name is Ben. I'm an engineer at Spotify. I have been at Spotify for a long time, 5 and a bit years now. Working on Backstage mostly. And I'm also maintainer of the Backstage open source project too. Flynn, you go ahead.
Excellent. I'm Flynn. I'm a technical evangelist with Buoyant for Linkerd. I mostly wrangle the open source side of the world. I don't remember how many Cloud Native lives we've done so far, but yeah, they happen regularly. It's always fun. We shall, I think we have a few slides today to give some background for what we're doing, and then we will pray to the demo gods that our demo works.
Yeah.
As one is wont to do.
Yes.
It's going to be fun.
Yeah. So yeah, as we mentioned, I'm a tech evangelist for Linkerd. Ben is a maintainer of Backstage at Spotify. Ben also wrote the plugin that we're going to be demoing for Backstage today. So props to Ben for that. We're going to do some very quick introductions of the problem space, of service meshes, of internal developer platforms. We're going to talk briefly about Linkerd and about Backstage, and then we're going to go and do the demo. And like I said, there's a certain amount of praying to the demo gods that is relevant. I've just realized that my name on these is covering up the Spotify logo. And so I would like to apologize to everyone at Spotify for this. If I recall correctly, there's not a way to turn off the nameplate for the screen share. So sorry, Spotify. We didn't mean it. Problem spaces. So pretty much everything in Cloud Native, we've decided to go in whole hog on microservices, which works really, really well in a lot of ways, but requires you to know a bunch of stuff to really get things done. Starting with the one that sounds really obvious, but can actually be really difficult. You actually need to know which microservices are running in your cluster. You need to know what they can do. You need to know what version they're running of a particular piece of code so you can go figure out problems. You have to trust these things. You have to be able to tell when they're working or when they're misbehaving. You also have to know who to talk to when a microservice is misbehaving so that you can hopefully get it fixed. And if you're doing this in a 4-person startup, this is usually relatively easy. If you are doing this at Spotify or Uber or Google or, large organizations, keeping track of all of these things can be really, really, really hard, in addition to the whole whether you can trust them thing. So service meshes fundamentally help you trust the microservices. And as we're going to find out, they also help to surface information that you can use to watch the microservices. The internal developer platform, internal developer platform. I don't know why I always say that. They kind of grew up as a way to help you know all of the other things about the microservices that you need to know. What is running, who's responsible for it, all that kind of stuff. The service mesh itself is dealing with the fact that microservices applications involve microservices communicating over the network all the time, but the network is fundamentally insecure and unreliable, and also hard to see what's going on. So service meshes are infrastructure components that add security and reliability and observability to your application at the platform level, uniformly across the entire application, ideally without requiring you to change your application. And they watch all of the communications between all of your microservices. So they help a lot with the trust part. And if Ben would be so kind as to explain internal developer platforms, that would be lovely.
Yes, I can do that. So what is an IDP? So I guess IDP can mean two things. It can mean portal or platform. And I guess they're kind of still, they're variants of the same thing, right? One's just more of a through place, which will link you to other places. And the platform is more, you spend a lot more time there. So like, what is an IDP? So it's a single pane of glass for your engineers at a company. So what do I mean by that? And it's like engineers should treat this as like the Google basically inside your organization. So it's the first place that they go to when they want to see the running state of like their applications. They want to have a look at monitoring, login, stuff like that. They should go to the internal developer portal platform to find the right place. So it's highly customized to your organization's need. So I've worked in a lot of different places, and not one of them have had the same tech stack, right? So like trying to understand how to deal with all the internal, all these tools that you use for monitoring, for login, can be kind of, it's kind of a lot of overhead. Service catalogs, so being able to kind of index and see all of the running software or components of your organization into one place, and increasing developer productivity. So like I said, every company is different. Every company uses a different tech stack for login monitoring. Like if I'm new at a company, or if I'm branching out and doing some other stuff with something I'm not familiar with, like me learning the tools that we use at an organization to do login, to do monitoring, can be kind of tricky to get my head around, right? And it can take, sometimes days to set up new components. Let's move that into a developer platform where I can do something that's a little bit more self-service. An engineer can fill out a form, fill in some details that they want for like a new component, and then it's going to go ahead and create that component for me and add it to the service catalog or software catalog. Yep.
That point that Ben just made about self-service is important too.
Yes.
Sorry, go ahead.
Yeah, I can carry on. So yeah, both the service mesh and IDP help make developers help themselves, right? So like instead of, they can help themselves a little bit easier. They can go there, they can fill out forms and stuff like that, instead of like, trying to work things out and call the different teams. And this is a huge factor when you're trying to help develop a scale, right? Rather than trying to operate a scale, you're basically developing a bigger scale.
In a lot of cases, we know fairly well how to operate at scale, in that we kind of know how to throw more hardware at the problem and how to scale horizontally and how to do all of this stuff. Developing at scale is a little trickier. We know pretty well how to develop in teams of 10 or a dozen, but when you get up to teams of hundreds and thousands, things get trickier. And this is one of the things the microservices architecture is really good at, but we have also found that you really need to have your different teams on different microservices able to just run full steam ahead and do a lot of things on their own, rather than constantly getting mired behind operations or something along those lines. So self-service is a big deal. All right, Linkerd. So I mentioned that Linkerd is an infrastructure component offering security, reliability, and observability at the platform level. If we start off with your typical microservices application, where you've got a bunch of microservices all talking to each other, the way Linkerd works is by sticking proxies next to each of your application containers, really. All right, fine. I'll explain that, since I said something different than what the slide says. We add proxy containers into each of your application pods so that you have a proxy container inside the same pod as your application container. And this is important because it means that the proxies end up following exactly the same life cycle as a Kubernetes pod. And it fundamentally makes them operationally more simple, because they follow all of the things in Kubernetes that you already know how to do with pods. That also turns out to be important. Once we stick those proxies in there, we then take over all the network communication and allow the proxies to mediate and measure everything happening over the wire between different application workloads. So we add MTLS to do security. For reliability, we can do automatic retries, we can do timeouts, we can do circuit breaking, we can do funky routing. There's a bunch of stuff like that that we are in a position that we can do. We can also, since we're measuring everything, we can surface golden metrics like the request rate and latency and your success rate and all this stuff to make that available both for the humans to see and for other tools to see. We also have the ability to just go in live and watch things in real time, watch each request as it happens, which can be a very powerful diagnostic tool.
Yes. And Backstage is a open source framework for building your own IDP. Yeah, it was open sourced 3 years ago, I think, by Spotify, donated to the CNCF. We've got 2,500 and counting adopters now. Kind of based around three main concepts, right? So you have the core framework, which is things like a design system and tools to help you integrate with integrations like GitHub, GitLab. And using those, you can build plugins, and plugins can be cards, they can be tables, they can be entire pages. And these plugins are designed to basically surface the information that you think is important to your engineers. So they can be custom made, they can do them in a source, or you can use the hundreds of open source ones that we've got. And then you have the app, which is basically what you see in the browser, right? Like it's the web page, the entire app. And this is basically a collection of plugins. And like I said, you can choose and pick which plugins you want to use. We, out of like Backstage, we have plugins like the software catalog, which is kind of the service catalog stuff that we were talking about earlier. Scaffolder templates, which is the kind of self-service part, going to go create your own components. Tech docs to do documentation, see all the documentation for all of your components in one place. We've got plugins for Kubernetes to be able to see like the running pods, deployments in all the different clusters you might have. Plugins for builds, CI/CD, GitHub Actions, all this stuff, test coverage, the list goes on. And obviously now Linkerd 2, which we're going to show you soon.
Woo!
Yeah.
Okay, let's talk really briefly about the demo application we're going to be working with here. This is the Faces demo at GitHub Way.io Faces demo. It typically looks a lot like this in the browser when you first install it. Under the hood, we have a cluster. We have a web browser, which is the Faces GUI loaded up, a single page web app. The GUI talks to a workload called Face. The Face workload talks to the Smiley workload and to the color workload. Smiley, as you might expect, is supposed to return this grinning smiley face. The color workload is supposed to return this blue color. Face composites the two together, and that tells the GUI what to show. Oh dear, I didn't correct this slide. Often we run this using Emissary as an ingress controller. We're going to skip that part this time just to keep the demo lean and mean. We're going to allow the Face workload to kind of be its own ingress controller. And we'll talk a little bit about that later. It's a bad idea to do this in practice. We are going to have Linkerd in the cluster going through and doing all of its meshy sorts of things to mediate communications, to manage it. And we are also going to be putting Backstage into the cluster so we can see a lot more about what's going on. You should, in every cell in the GUI, always see this grinning face on a blue background. But that is not what you are actually going to see when we install this. You will see lots of other things because Faces is deliberately designed to be deployed in a way that frankly doesn't work very well. So we can go through and dig into what's going on and try to fix it. And with that, it is time to pray to the demo gods and hope everything works out correctly. Oh, that's a very good sign. It switched over the terminal correctly, at least. Okay. We are assuming, as we start this, that the cluster is empty. We don't have anything going. Ben has cleverly arranged for the cluster to be empty half an hour ago. Thank you, Ben. We are using a Civo cluster for this from www.civo.com. The demo doesn't really care. Pretty much any Kubernetes cluster should work fine for this demo. So we are going to start by installing the Faces application itself. We could do this in lots of different ways, but we're really, if you sit back and you look at it, in a lot of cases, people already have something running at the point that they decide that they need to install a service mesh or they need to install an IDP. It's a little more rare for people to sit down with a totally blank sheet of paper and go, oh yeah, I think that I need to do a service mesh and an IDP, and then I can start working on my application. So we're going to follow that kind of more common path of you have the application first and then you add other things to it. Yeah, Helm, I know. I know my configuration file is group readable. It's okay. There's nobody else using my Macintosh. All right, let's make sure that actually worked. All things considered, that looks good. And if we go over and grab this IP address and paste it into the browser, we should see a working Faces demo. Yay! And you can see this is not working well. In particular, we can see a lot of things that the key identifies as being problematic. And so, yeah, let's flip back. The big problem here is that although we can see as humans that things are going horribly wrong, the Faces application itself doesn't really give us anything for trying to figure out what is going wrong. We know there are 4 microservices running. That's great. We could ask for logs for the microservices, but Face was not written to, the Faces applications were not written to do any particular observability from inside the microservices themselves. So about all we have to work with here is the commit so that we can at least know, well, we can at least have a fighting chance of knowing what version of the code is running. But, this workload is taking traffic right now and its logs are pretty much empty. So we can start to fix that by installing Linkerd so that we can at least go and get some metrics that are, basically reasonable out of this. Quick note on releases for Linkerd. These days, the Linkerd project itself only provides edge release artifacts, which we build every week or so from the main branch so that they always have the latest and greatest stuff in them. They are a great way to go and try things out and help out the project. And honestly, they work quite well. So we're going to go ahead and use one of those. You can also get stable Linkerd releases via the vendor community. But for this, we are using an edge release. Specifically, we're using Edge 24.5.3, which is the latest and greatest. And given that we have what I just did here was to install the CLI itself. And now I'm going to use the CLI to install Linkerd. First, I'll install Linkerd's relatively small number of CRDs. And after that, we can install the Linkerd core itself. Everything that Linkerd does from the CLI, it will produce YAML that you then apply yourself, or that you check into Git and do GitOps with, or whatever your workflow works with. But it's important to know that the Linkerd CLI, excuse me, will never actually change your cluster directly. It relies on you to do that. We also want the Linkerd Viz extension. This is the one that visualizes some of the metrics that Linkerd produces. It is very, very useful. We tend to recommend people use it, but it is an extension because a lot of folks just want to build their entire metrics pipeline by hand rather than using Linkerd Viz. Let's go ahead and let that get running. I see a question over there about whether P is for portal or a platform. I don't know. Does it matter, Ben? What do you think?
I mean, so this, in this platform, right? Because there's kind of a plugin for Linkerd. It's not just linking to Viz. So I guess more of a platform this time. Yeah, they're kind of interchangeable, right? I think, to me, things can start as a portal and then turn into a platform once you add more plugins to them, once you add more, features to it.
Do you think there's really, while we wait for Linkerd to check over Linkerd's installation and make sure everything is working, do you think there's really a big difference between portal and platform in practice?
To be honest, no. I think there's just, people refer to things that give you click-throughs as more portals or on the platforms, but I think, to be honest, they're kind of really interchangeable. To me, I don't think there's a strong preference for us. I mean, I call it portal platform kind of interchangeably.
Yeah. All right. Yeah, I don't. You know, there are ways I can see people feeling strongly about what to call it, but in practice, I think they mostly end up being the same thing.
Yeah.
Okay, so Linkerd is now installed, and it's not doing anything right now. If we come over and take a look at our web browser, it's still running, it's still broken. So the next thing we're going to do is we're going to actually bring faces into the mesh. So we've installed the control plane of Linkerd, which is the part that manages the proxies I was talking about. The next thing we're going to do is actually attach those proxies to the faces application. We are going to do this the easy way. We are going to annotate the entire faces namespace to tell Linkerd that, hey, it's okay to go ahead and bring this into the mesh. And I said, once we do that, as I hit return in the correct window, then we need to go ahead and restart all of our faces deployments so that they pick up the proxies. You can tell this is a demo because it's taking just long enough for the deployments to happen that I look over and go, wait, what's going on? And if we flip over to the browser here, again, we don't actually see anything different because we still haven't fixed anything. The difference is that now we can at least go and get some information about what is broken. We'll do that by firing up the Linkerd dashboard, Linkerd Viz dashboard. And here's the Linkerd Viz dashboard. We can immediately see that the faces namespace does not seem to be doing very well here. So let's go and click into that namespace. A couple of things that happen here. One of them is we get this little graph where we can see the faces GUI is talking to the face workload, which talks to color and talks to smiley. This is a correct representation. Since, like I said, we're not really using an Ingress controller here, where I lied a minute earlier. I said the face workload was going to act as the Ingress controller. It's really the faces GUI workload acting as the Ingress controller. We can also scroll down and see that everything seems to be failing 20% of the time. So we still don't necessarily know what's causing all of these. We know that the color workload is failing. Okay, is that the reason why the face workload is failing, or is there more going on? We don't know the answer to that yet. We can go in and take a look at color, and then we can see here, oh, yeah, some of these things look like they're unhappy. We can scroll down a little bit and see that the only call happening here is that face is repeatedly just calling the slash path. And we can see that, yeah, that's not working all that well. We can also click on this microscope. So I just got a little bit messed up here by the fact that these got added to this graph because they are things that are part of Linkerd Viz. So everything resized and the microscope I wanted moved out of my way. If I click here and then I say start, then we will actually get to see live calls happening to the color workload. I will stop that rather than fighting the scrolling for a second. And for any one of these, yeah, you know, most of them I get 200s back, but then this one I get a 500. So I can come over here, click this disclosure triangle, and then I get to see the request headers and the response headers and some overall things about the response. So at any given point, we can go in and look. So at this point, I can now be certain that the color workload is indeed unhappy about something. Depending on where you want to go with this, of course, that's always just a first step. But one thing we could do is we could start thinking about, well, do we want to use the service mesh? Maybe it's safe to retry some of these things and see if it makes things better. Maybe I need to talk to a developer about this. Maybe I should just kill the whole thing and install a new version. And for all of those things, we start needing information in a broader context. So we will continue this by going and picking up with Backstage. Over to you, Ben, to walk us through how this is going to happen.
Yeah, so this is running out of a CNCF Live demo repo, which I'm currently in my GitHub account. But this basically, this repo is a Backstage create app or a skeleton, basically, that we create using the Backstage create app CLI. And it's going to basically give you a, the app that we spoke about earlier with some plugins baked in on like the core framework. And there's some default plugins in there, which we're also going to dive into and have a look at too. There's also some Kubernetes manifests in here, which we are going to show you now. So the main one really is the deployment YAML. The other ones are just kind of to update some of the metric servers and the service account for Backstage itself, so they can actually talk to the Kubernetes cluster. So we're just going to apply.
Is it worth looking at the deployment, or is it just a deployment?
I think it's fine. It's just a standard deployment. There's nothing really much going on.
And Taylor, I think you have the URL for the CNCF Live demo repo. If you want to toss that up, then anybody who wants to look at it can go look at it and see what exactly is in these files. But yeah, in the meantime, I guess we just go ahead and apply them.
Yep. So this is just going to apply the Kubernetes clusters so that we can apply the Kubernetes manifest so that we can deploy to the cluster. Then it's going to roll out. So this might take a second because it's a new image to pull down, because I pushed a new one 15 minutes before they started. So I'm hoping this works. Live demo is not live demo if you're not changing it 15 minutes before you're starting. But yeah.
I would love to tell you that I didn't do anything like that, but I also did exactly that.
It's going to be fine. It's just some small tweaks.
It'll be fine. Everything will be great.
I hope.
Yeah.
Otherwise, we might have to manually edit some deployments. But I'm sure yeah. So
one of the taglines for CNCF Live has to do with building things and breaking things. So,
yes.
But hey, it looks like it worked. So that's awesome.
It did work. So just to recap this, the report, when you run the create app script, you're basically going to get a back end and a front end to deploy inside a Docker container. So right now we're just deploying them all in one container, which is what the deployment does. There's a built-in Docker file and stuff that you get outside of the box too, to help you build, your Docker image that you're going to deploy. I spent a few hours basically setting up this Docker container. So what you're about to see is something that's a little bit more polished than what you get out of the box, but it's not far away. Normally, you would also deploy Backstage behind like some authenticating proxy or VPN or whatever. But for the purpose of this demo, we're just going to use port forward just to get access to the actual running Backstage pod.
That's the reason why the emissary logo is still in the slide deck, because we were originally going to do that and then realized we didn't really want to talk too much about all the setup that goes with using a proper Ingress controller. But at this point, I think it makes sense to go over to Ben's shared screen where he can run his very own port forward.
Yes.
And off we go. Oh my God, that worked. That's amazing.
So this is localhost 707. Like, it is actually port forwarded. I am running the port forward in a different camera. So this is kind of what you get out of the box. This is the software catalog that we can see. We see my company catalog here, customized for this demo. As you can see, my company is the company that we work for. Of course. This is the catalog. We have some demo data loaded in here. This example website. So I am just going to click into this example website. So this is what we would call the entity page. So the entity page is basically very customizable, and it uses quite a lot of plugins, whether that be cards, tables, the tabs that you can see at the top here. These are all plugins that you can install into Backstage. When we click on one of the components that we see, this is just a demo one, like I said, we can see some information about the component. So we can see who owns it. We can see where it belongs in the ecosystem model. We can see what type it is. So this is a website, for instance. We can see if it's production, is it experimental, some tags. We can also see relations to other catalog entities. So, for instance, we've got users and groups, what APIs it provides. And there's this is just some basic demo data here too. I also have tabs for CI/CD, Kubernetes and dependencies. So these are not going to work in the context of this entity, because this is not really deployed. It's just a demo one, but I just show you that it's not really set up. But let's go and take a look at what it looks like for something that is set up. So this is deployed in the same cluster as the Faces demo. I am going to import. Well, we basically need to tell Backstage and the software catalog about the Faces stack. all the components. Sorry, that's my dog in the background. Just bear with me 1 second.
Yeah, that never happens. To fill in what Ben will be doing once he comes back is the first thing we need to do is to tell Backstage about the existence of the various pieces of Faces, which I believe you're going to do by importing the catalog file from the Faces repo itself, right?
I am indeed. Sorry, they're building like an underground subway here in Stockholm, so they blow up basically the new holes, and the dog goes crazy. Anyway, sorry. So let me just grab the Faces demo. So I've got some sample data over here. So yeah, to get data into the catalog, there's a multitude of ways to do this. You can, if you've got an existing data store, for instance, you can write integrations to basically populate the catalog from your existing data. Or, we recommend that people write catalog info files and then store this alongside like your actual source code for the service. So for instance, here, this is like the actual code that makes up the Faces demo. And I've just added a entry in here which defines the components that are actually running. So you can see we've got components for the Faces GUI. We have a component for the actual face service itself. We've got one for the smiley service and so on. So yeah, this maybe doesn't all live in the same file. Maybe it lives alongside the code in other places in your GHE, GitHub, whatever. But for the purpose of this, it's just all inlined into one file. So
is there a best practice there? Do y'all recommend that people have them in multiple files or one? I mean,
I think it depends. It's entirely up to you how you want to structure it yourself. It's pretty flexible. I mean, internally at Spotify, we have a lot of these files everywhere. We have a lot of services, right? Sometimes it might make sense to define things in one place like this. This repo doesn't really. I mean, it builds multiple Docker containers, right, which are deployed in the manifest in the Helm chart. It might make sense to actually move these and put these alongside the actual Go code itself. But yeah, it depends how your project's laid out and what the structure of it is, right? It's sent out to you, super flexible. Like I said, they also doesn't have to come from YAML files, right? You can write providers, entity providers, what we call them, which are basically just like little node lambdas, which are going to go and crawl some endpoint and produce this kind of format, but you don't have to start with the YAML file. You can also take existing, if you have like a similar sort of metadata file like this today, you can use that existing metadata file and just transform it into something that looks like this. Super in that way. So I'm going to go and track this now in Backstage. So we're going to go into create. I'm just going to pause here and show this quickly. So this is the scaffolder plugin, or the create component in Backstage. So when we were talking earlier around reducing the time to getting set up and onboarding and making things easier, this is kind of what the scaffolder does. So the scaffolder is going to present the user a form to fill in. So this is kind of also a super basic example here, but it's going to ask the user for some input parameters, maybe a name for a component, maybe where they want to deploy it, where they want the repo to be. And then when we click next and go to create, it's going to go and create a Git repository with some code in there for you, which has got all of your company's best practices baked in. So, with monitoring, login, all that stuff's going to be set up already for you. You don't need to worry about it. It's just going to make things a lot easier. Not going to show too much of that today. There's a lot of talks around the scaffolding stuff, which I've done personally myself, if you want to go and check out. So we're going to register an existing component. I'm going to go and paste in this file here. It has detected that there's quite a lot of things in this file. So, there's a component definition for the color Faces GUI, the smiley that we're just looking through, and some API definitions too. I'm going to go and import this. And then if we head back to the catalog, now we can see our additional entities in it too, which is great. So let's go to the face service. So you noticed before on the old component, I didn't really call this out, but there's a little banner at the top that said that this service is not meshed. And that's basically the Linkerd plugin checking that component, does it exist in the mesh? And it's going to warn you if it's not. Like I said, all these parts out of the plugin are basically building blocks. You can use you can choose to use it or you can choose not to use it. It's entirely up to you. Like we just built a little banner because it's kind of nice. It's making things visible that things are not in the mesh. It's good. Nice. Yeah. So this is the face component that we just ingested. We can see how it fits into the catalog, all the relations here. See more information about it, like I've just called through, who the owner is. And now we have the CI/CD tab, Kubernetes. We have, all the tabs that we had before, but we also have an additional Linkerd one. I'm going to come on to that in a second, but I'm going to just step through some other things that you can get out of Backstage, like the CI/CD tab. So I'm hoping this is going to work. Yes. So the CI/CD tab here is going to basically go to GitHub Actions in this case and check the builds that's been going through for this component. So this is kind of useful, like if we're trying to work out what is broken, I can actually see the deployments and the releases that's gone through recently and go, hey, it looks like this release might be broken. We're seeing some weird things happening. I can see all that here. I can go.
That's actually really fascinating because that's particularly fascinating because it's grabbing all that stuff despite the fact that I did absolutely nothing to enable that.
Yeah.
So.
Yeah, it's we can step through a little bit more. So there's like we can actually see the build details itself a little bit more without having to like go out to GitHub, find the workflow, find the run, or if you're using Jenkins or something else, like it's much easier to be able to see this all in one place, like this in the context of an entity.
That's pretty awesome.
Yeah, it's super nice.
Yeah, I mean earlier I mentioned that Faces does log its, it logs a commit ID. But of course, it doesn't really log the repo it was built from or anything like that. So being able to just easily do this and get to this level of information is great.
Yeah, for sure. So this is nice. We can see all the little steps that make up the GitHub workflows too as well. Head over to the Kubernetes tab. So this is all set up to basically talk with the Kube API that's in the cluster. So we can basically dive in to some of the things that are deployed that make up this Faces service. So we can see we have a Face deployment and we also have a Face service itself. I can click into the deployment. I can see the pod that's running here. I can click into the pod and get some more information about what makes up this pod. So we have the Linkerd proxy that's now deployed alongside. We can the Face service that doesn't have a readiness probe set.
I was face palming because now everybody knows that I didn't put a readiness probe up for. All right, got to go fix that afterwards.
And we can see some basic high-level information from Kubernetes from us here. There is also the option to enable logs. I haven't just enabled the permissions for the service account, so that's not going to work. But we will be able to see the same logs that we were getting from kubectl earlier, too. So I also want to call out documentation. So one thing I thought about is, so I have some docs here. Where is the docs? Oh, README. So I have a README here, right? So it would be great if, I'm in Backstage. Do I really have to go back to GitHub or go where this code is stored to be able to see the documentation? I'm really hoping this works. This is a place when we cross our fingers here. I should be able to see the documentation inside the context of components. So this is the Faces demo, right? README, I can see all the documentation. Like this is, again, just a basic demo of just showing the README, but you can see how powerful this would be of like showing, maybe it's a run book, maybe it's, getting started, like contributing guides for all the different components too. Like there's a lot of things that we can add here.
That's really cool.
It's nice. It's good. I mean, it's also like really collaborative too. So you can choose to like edit this, create suggestions for it. It's going to go and, actually edit the markdown that this comes from. So I can actually create suggestions for people and say, hey, I actually ran into a different issue here when trying to set this up. It's kind of nice. It's good.
What's the API tab before you get over to the Linkerd
API tab. So I'm gonna make this a little bit bigger because it's kind of squashed on my screen. I think it's also squashed here too. I don't know if this is going to make the stream a little bit weird, but
looks better.
Yeah. So we can define what sort of API. So APIs are another kind that you can store in the catalog, and we can create relations between components and APIs for if a component consumes an API or if it produces an API. And we can click into these APIs and get a little bit more information about them. So I can actually click on, again, this is another entity kind in the catalog, customizable page. You can do whatever you like here too, but this is kind of the basic one that you get out of the box, where we can actually see the definition for the Faces API inline. We have a nice little Swagger component for you to have a look at too. We can see information around the properties for the actual API call itself, the parameters, where it takes, the schema basically, and some, the raw API, open API schema here too.
Cool.
Which is super nice. Let's go back to the Faces component again, because the last thing we all want to see is the Linkerd plugin, right?
I want to see it.
Yeah, I'm really hoping this works. Okay, so I want to preface this with this plugin is under very active development. I'm also not a designer, so there's some design changes, I promise.
So what I'm hearing is this is an open source plugin, and any designers out there should feel free to submit PRs. That's what I'm hearing.
Yes, definitely. I would really like some help on building this and making it shiny. But yeah, so we can see this plugin under the hood. It's two things. It's a backend plugin and a front-end plugin. I haven't really spoke around what the difference is in them too much, but they're both written in TypeScript, both written in Node. One is a React plugin, which basically provides these cards for you to use as like the banner that we saw earlier. And the backend plugin is basically deployed with Backstage 2 in the cluster, and that backend plugin is basically responsible for hitting the Viz APIs, aggregating data into more of a view model basically, and then we call that backend plugin with the front end plugin and display the data basically. So we have the network graph that we kind of saw from Linkerd Viz earlier. So
and that's all completely dynamic, right? That's just getting pulled directly from the Linkerd metrics.
Correct. Yeah. So this basically just hits Linkerd, but Backstage is an aggregator of data, right? It's never really the source of truth. So in this case, Linkerd is the source of truth. We're just basically aggregating all this data together for you to see it. Right. So you still need Linkerd to see, to actually use the plugin. The plugin doesn't give you Linkerd. You still need to have that running. So yeah, it's going to basically hit the APIs and provide us some nice in-context entity data for Linkerd. We can see the graph, incoming and outgoing. Again, not a designer, might want to do some improvements here a little bit. We can see incoming and outgoing edges for basically, I am the face component. We can see that inside. I have incoming requests and outgoing requests. I can see these components here, what they actually map to in Backstage too. So if I can see there's an error with some of them, or the success rate is not great. So this one, for instance, 78% outgoing request to color. I can go into this component, and then I get the entity page for that. Maybe here this has got a different owner, right? And then I'll be like, hey, your service is misbehaving. Maybe there's a PagerDuty plugin here, which is also an open source plugin. And you could page the team that owns this. Hey, something's broken. This is not working. If this was to happen right now, it would just basically ring you, Flynn, I think.
And in fact, we can fix. We can go fix the color workload. Shall we do that now, or shall we do that later?
Let's do that. I think we can do that now, right? So let me go ahead back to the Faces service, and I'm gonna. Face. I'm gonna pretend that I have just pinged you and telling you, can you go fix your stuff, please? And I guess we're expecting these metrics to change, right? Once the color service gets fixed.
So I'm gonna fix this workload by executing a very complex command, which Taylor has in the chat. If you want to go ahead and publish that. Faces is designed so that it has environment variables that tell it how often to fail. So I'm going to fix this by setting the environment variable to 0. So it should just work all the time. And Ben, if you go over and look at the Faces UI in your browser.
Yes, 1 second. I have lost that. Give me a second.
74.220.20.85.
Hold on, I think I have it. Yes. Quick panic there, but we have it. Yes.
So you can look and see that there are no more gray background cells. They're all blue or purple. And that tells us a couple of things, but one of them it tells us is that the color workload is working now. And so now we can go back to Backstage and see whether or not any of our stats have changed.
Yes.
Like the color one, which is now showing 100%.
Yes. Nice.
So that's also interesting because from here, since Backstage knows that face needs to talk to both color and smiley, it's also showing us the success rate for smiley, which is still failing. Yeah. So maybe the fact that smiley is failing is causing face to fail as well. So we can go ahead and fix smiley while we're at it. This is exactly the same command. I'm just changing the environment variable for the smiley deployment instead of the face instead of the color deployment, and all the cursing faces should go away. There we go.
Yes.
So I think it'll probably take Backstage a little bit longer to catch up because Linkerd's metrics need to catch up, and then Backstage needs to get them from Linkerd, right?
Yeah. Yeah, the UI pulls it like once every 5 seconds as well. I mean, we could make that changeable, right? Like, I know.
Kind of no point, really.
Yeah, it's going to settle eventually, as long as it's not like 30 seconds. Yeah. Like,
well, if you go back, what is Backstage saying right now?
Hopefully, it's 100%.
It's saying 100%. Cool.
Like, you just need to wait a little minute, and it's fine.
Yeah.
Yeah.
So, yeah, I mean, the thing that I think is, well, there are actually a couple of things I think are really cool about this. One of them is all of this information about the call graph and things like that is all dynamic. The Linkerd plugin for Backstage that Ben has done intuits the call graph based on the metrics coming out of Linkerd. So if we go through and change things, the graph just changes and the metrics that it's showing you reflect real time. And this is pretty awesome. I think we have enough time to do this other demo where actually, Taylor, can you flip? You know what? Never mind. Let's not flip back. What I'm going to do is I'm going to deploy a second color workload. It'll be called color 2. It's exactly the same thing as our existing color workload, except that it has its own Kubernetes service, also named color 2. And it will be returning the color green rather than the color blue. So I'm just going to go ahead and do that over here. You can't see me typing this kubectl apply command, but I just ran a kubectl apply command. And nothing should look different in Backstage yet because there's currently no traffic going to color 2. And also, we haven't defined a component for color 2 yet, right? But, and also if you go to faces right now, then you shouldn't see anything different in the faces app, I don't think. Can you flip back over there? Yeah, so we all see blue. But now I'm going to apply an HTTP route that tells Linkerd to do a 50-50 split where traffic destined for the color service is going to be split. So half of it goes to the color workload and half of it goes to the color 2 workload. I just applied that and you start seeing green things showing up. All of this is stochastic, so we won't necessarily see exactly 8 cells or anything like that. But if we flip back to Backstage now, I think that if we give this a little bit of time to update, that it'll shortly show us the color 2 part of the world just automatically.
Yeah. So we have
something just changed. There we go.
Edge here, there just popped up. So I think it should update the graph. There we go.
There we go. Now, this is also incredibly cool because this is exactly the scenario where one of your developers decided to go and do something without telling anybody that the call graph is different. But you can see that now, as opposed to just being stuck because some random developer did something at 8 p.m. on a Friday night and didn't tell anybody before they ran out for beer. Not that that ever happens in the real world, you understand? You know? So the question that just popped up is the graph depth configurable or is it always 1? I don't know. Hey Ben, is the graph depth configurable or is it always 1?
So I have toyed with the idea of making this like not unlimited, but I never got around to implementing this. But I think it's a really kind of cool thing, right? Is that
yeah.
I mean, the backend data on the store is like Prometheus, basically, right? So it's Prometheus is what stores pretty much all this data which we pull from. So it's going to put a lot of strain on Prometheus, maybe, to like do kind of a bigger service mesh or like bigger graph. I don't know. I've not tried it. I don't know. But I have thought about maybe supporting, having a bit more configurability, because also if you were to take this in the context of face, so face is always in the middle, right? And if you have more upstreams and more downstreams, being able to see that graph, and then also I'd like the element of color in it that we don't have right now. So you can actually see where things break in the graph and what it actually affects, like upstream and downstream dependencies. Like, that's kind of cool, right? That's super useful. Being able to see in real time, like what is broken from every request and what is talking to what. That'd be cool.
That's the thing that that Linkerd Viz does, is it shows you. It can show you colors to talk about where the failures are. It's like, on this graph, I would actually love to see the edge itself showing a failure, right? That would be amazing. There's, I mean, as we mentioned before, active development, there's a lot of stuff that could be done here, but even as it is, it's pretty cool. And I particularly love the bit that even though we didn't define the color 2 component, we still get to see it, and we still get to get information about it. And I think, was there anything else that you particularly wanted to show, Ben? Or
no, I think I can. I mean, I could make something up to show, but not really off the script. One thing to kind of call out here is the TLS stuff is kind of interesting, right? Being able to see. We could obviously get MTLS, so services can talk to each other securely, right, without having to do anything yourself manually. You can just roll out Linkerd, right, and it's going to talk over HTTPS. So, like, there or thereabouts. You can fill in Flynn here if I'm making.
So far, so good.
Yeah. Okay. Good. So being able to see like where network is secured or not is kind of really interesting, especially for like bigger companies, right? That actually,
it's a huge win for compliance.
Yeah, for compliance is really good. And the one thing I've not really spoken about for Backstage is Tech Insights, which is another plugin that's open source. And it's kind of like gamifying a little bit, like software standards inside your organization. So you inside a company can be like, hey, we should be running Java version 20, right? And if there's components that don't adhere to that, then they get a little cross, no, you don't run it, you need to update it. And it's kind of like scorecards, basically. And, making this gamification of like making sure that components that you own are, up to date and are adhering to software, like company best practice, right? And because this data is now stored in like a backend plugin, for instance, there's nothing like stopping us integrating with this and going, okay, does this component talk over MTLS to every upstream and every downstream, right? And we can get that information now in Backstage, right? And create these checks that can check to see if things are secure. Like, there's a lot of different things. If they're in the mesh, we already have, APIs for seeing if things are in the mesh or not. Like, that sort of stuff is kind of really, really cool.
It's also worth noting that Linkerd can be configured to refuse any connection that is not using Linkerd MTLS. But we don't ship it that way out of the box, because shipping it that way out of the box is a recipe for disaster when you add it to an already running application. So that checkbox there about whether this connection is using MTLS is extremely valuable, because it lets you know both for the compliance, but it also lets you know, oh, hey, I bet you this component hasn't been meshed yet. We should go figure that out. We should take a look at it and see. There's one other thing I wanted to call out about this, which is that we originally showed up with this question of, hey, Faces is failing a lot, but we don't know why. We don't know what the problem is. I just wanted to point out here that we can see, Ben, if you flip back over to there, you'll still see some of those frowning purple faces, right? And if you flip back to Backstage now, you will see that we still have only a 70-odd% success rate from, when the Faces GUI is trying to talk to the face workload. So we have actually gone through an engineering exercise and demonstrated that even when we fix all of the downstream dependencies of the face workload, the face workload itself is still failing. And we kind of did that without even really talking about it explicitly. It just fell out of, well, let's go through and start looking at some of these things. So even when you're not specifically, I guess, trying might be the right word, once you bring all this information together in a single pane of glass, you actually have an awful lot of opportunity to learn new and interesting things about your application and to be able to really make things better just by going and having all this stuff at your fingertips, which is pretty nice. I see one other question there about whether we can see response text in the Linkerd dashboard. So the tap functionality, which I think is what you're talking about, where I showed the response header, request headers, response headers, and such, that will never ever show you body data. It will only show you the header data. The header data itself can be sensitive anyway, and this is a reason why we strongly recommend that you deploy the Linkerd Viz dashboard only behind something doing authentication for it. In our case, we didn't make it visible at all to anybody who can't run a port forward. That can work pretty well in some cases, and it can be a really terrible idea in other cases. So your organization kind of has to decide how you want to approach that. I've also had, it works really well to put it behind an Ingress controller and let the Ingress controller handle user auth as well.
Okay. Awesome.
Any other? I think we have a couple more minutes for questions. If there are
we have about
any others?
3-ish minutes for any more questions. If people would like to ask them through the chat, I'll wait on this. Normally I have other questions, but since there's 3 minutes, I'll give people just a second if they had any questions they were typing up. And if not, we can probably wrap up from there.
Cool. There were 2 other things that I could show in terms of slides. Actually, let's do that. Let's do that while we're waiting for questions.
If you have a call to action, that'd be great to have. Let me pull back up your screen for you.
So there's a Linkerd book from O'Reilly by me and my colleague Jason. So hopefully it's good. Pick it up. Let us know if you think it's good so we can fix it if you don't. And every month, Buoyant does Service Mesh Academy. We will be talking about IPv6 with Linkerd next month on June 13th, which is a oft requested feature. So if you're interested in that, drop by. And other than that, I think that is it.
Awesome. Well, thank you everyone for attending today. And thank you, Ben and Flynn, for the great demo and explanation of these 2 awesome technologies working together.
Thanks for having us.
Yeah, it was really great to see it. And thanks everyone who attended and participated. And we'll see you all at the next Cloud Native Live. Bye, everyone.